cases will define what the functional use cases will define how the hardware should look like, but there are some aspects which ought to be considered as any IoT hardware kind of should or must have kind of items. So the first thing is the offline data storage. So IoT devices are meant to transfer data to the cloud. So how much data you can store offline when there is no connectivity, and how important that data is something that you should determine and must have in your mind when you design the hardware. The second is the power management. So there are battery operated devices, or whether there is abundance of power will determine what level of power management you would require. The third is remote diagnostics, without which you cannot just ship the hardware, because with remote diagnostics, if there are issues on the field, you ought to get the issues immediately using SMS or email alerts, and not waiting for customer to complain and then sending a person. So all your profits otherwise will be eaten up when you send people around doing the diagnostics. Then the longevity. Do not fall prey to cheap hardware which is not going to last for a year or so. You ought to have a hardware which will at least last for 5 to 7 years. But the most important thing is the over-the-air firmware upgrades and the configuration upgrades. It has to be feature zero. If you don't have this feature in your hardware, you are going to have field visits like anything, because IoT is not something which is kind of a project which has a software access. It is a project, or it is a solution which talks about field sensors which are miles away from you. You cannot send people every time for a small problem. So these are some important aspects. Then we talk about communication technologies. Now there are two types of communications basically. One is when the devices would communicate to the equipment, or the IoT devices would communicate with the equipment directly on one-on-one basis. Say for example excavators or trucks or these kinds of things, where you have one device, one IoT, one equipment and one SIM card. So these are typical M2M scenarios, and these directly communicate to cloud. But there are scenarios where you would have an array of devices within a premise. So for example, a factory would have hundreds of machines connected in a local wireless network, and then using that local wireless network or a single gateway, you would transfer that data to the cloud server. So we're talking about the second case here, and there are many technologies available like LoRa, Sigfox, BLE, ZigBee. But what from the perspective of maturity, from the perspective of cost, from the perspective of range and the power ratings, at the moment proprietary RF or sub 1 gigahertz RF seems to be doing really well. I am really bullish on LoRa, but with the adoption coming in and with the market more maturing on this side, the cost will decrease and the adoption will increase, but that may happen a couple of years down the line, not today. Today I think if you are to implement any of these solutions, proprietary RF works the best. Coupled with mesh, it actually works even better. So if you can implement your own mesh protocol, then you can actually get maximum range up to several kilometers as such. And then we are thinking of communicating north. So these edge gateways or IoT gateways will typically have these protocols embedded into them. MQTT being one of the most popular protocols at the moment, but there are others like COAP or IoTVT that come across. And I'll just quickly glance through some of the items that you need to consider, which are the communication mediums. So at times you may want to have two communication mediums. So if one fails, the second takes over. So that's one thing that you have to consider. It has to be secure. So security is a must. We've spoken on multiple times today, so I won't dive in deep here. This is something that you need to consider if your applications are at remote places where there is absolutely no connectivity. For example, consider an underground mine where you have no connectivity whatsoever. So what you can do is you can have data loggers or smartphones collecting data using Wi-Fi, Bluetooth or any of such technology, and then transferring that data when that data logger is in a network zone. So this is something which is not normally considered by IoT service providers, but has to be. And then there are regulatory compliances like GDPR or any local compliances. that have to be considered right at the beginning, because you don't want to fall in trouble after things have been implemented. Now moving on to the cloud application, people will talk about scalability, people will talk about data acquisition, security, privacy, and in everything, but that's business as usual. So half the people here will easily be able to implement this. So what's big deal about implementing a cloud application? The big deal is how you can quickly start the project with minimum investments. When is that you are going to get an ROI? Are you talking about 6 months, 8 months, 18 months, or 3 years, or 5 years, or whatever it is? And how can you avoid vendor lock-ins? So these are some aspects which are not very much aligned to your normal software development process, but it is a completely different process where you have to really think in terms of the cost which is going to be incurred today as well as 5 years down the line. So we at ThoughtWorks typically believe in coming up with disruptive services or disruptive applications, and hence we thought of coming up with a model wherein everything is going to be pretty modular. So if you see, there are modules which talk about data collection from telematics devices and from third-party enterprise systems. Then we talk about a data lake being formed and a secure access to the cloud. And the most important part is the microservices part. So if you see those microservices, those help you build important functionalities without even wondering or waiting for other aspects to be implemented. So you can very quickly come up with functionalities which are going to yield results in 6 or 8 months of time, whereas nice to have or wish list can be implemented at a later point in time. I will explain this with an example in the later section. If you have to avoid vendor lock-ins, you have to use cluster deployments using Kubernetes or Docker images. You can execute using clusters, and once you do that, you'll be able to put your binaries on any of the platforms. So in such a case, you don't have to use IoT as a service, AWS IoT as a service, or Google IoT as a service. You can use AWS IoT as a platform and then use your binaries on top of it. So tomorrow, if there is Google who's providing the platform as a service at half the rate, you can easily migrate in say 1 or 2 days. If you're worried about your own data security and want to deploy it on your data centers, you could easily use this model to deploy it on your own data centers. And even the gods needed support. So earlier you start with the support team, better it is, because the support team has to know about what business are you getting into. The support team needs to know about the hardware, they need to know about diagnostics, they need to know about over-the-air firmware upgrades, configuration upgrades, and the earlier you start, better it is. And now you can think of AI and ML. So typically AI and ML comes into picture after 3 or 4 years, because when you collect data, then you can form models onto it. The normal course of action today is, first thing that a platform sells itself is because of we've got so many MLs, algorithms for MLs and AIs and so on and so forth. But how are you going to create algorithms and test it if you don't have data? So the first and foremost important thing is to collect data and keep it. And then once you start getting your return on investments in real-time monitoring or day-to-day operations, then start implementing these. I'm not saying these are not important. These are extremely important. But the priority has to be right. The decision has to be taken at the right time when you have enough data, not on day one. So let's learn with an example. Let's consider a truck manufacturer, a truck OEM, who wants to implement an IoT solution. Now, if you think of the stakeholder map, you will find the OEM itself, the consumers who could be fleet owners, could be rental companies, you could have dealers and the drivers. Some people try to miss out 2 important aspects which are from the allied industries, which are banking and insurance. But if you just think of this whole picture right at the beginning, you will be able to build a solution in a better way going forward. So the stakeholders have to be there on day one. This is just a sample list of problems. It's with the truck OEMs, the problem list is huge. Just 2 minutes. So I hope you've considered the time lost. So these are some issues that will come across as a when you sit across with a truck manufacturer, but you don't have to consider all of them. Maybe you just consider what are declining markets. I mean, something which is going to have an impact on sales or aftermarket revenues. Fuel monitoring, again considering India as the market. And finally, there is some intelligent guy in the room who thinks that 1 year down the line, cold storage logistics is going to be a good industry. And probably if we start thinking about that right now, we also implement reefer van monitoring solution. So we just add that from the future perspective. We only focus on 4 parts. Hardware, I am not getting into the details, but just one piece here. Try to get a standard hardware from somewhere else, the reputed company, so that it helps you test the whole ecosystem quickly. Plus, you get a reference on how and what is to be implemented. Field feedbacks are fast. Typical hardware development cycles are anywhere between 9 to 12 months. It takes about 3 revisions for you to get the right hardware if you're really, really good. And on an average, it takes about 4 to 5 revisions. So if you wait for your hardware to be developed, you're going to wait till infinity. That's not what we want to happen. And when you try to develop the cloud application, these are the things that will fall in front of you. But do you start with all of them? No. What you do is you only start with some basic stuff, which is this part, and then try and build the complete ecosystem around it. So what you're trying to do is the 4 use cases that we spoke earlier are being taken care of, which takes care of an ROI between which is about 6 to 8 months or about max 12 months. Then go live as soon as possible. By meaning go live, I'm not saying go live for customers, go live for internal stakeholders, which are your testing teams, field testing teams, and so on. Once you do that, you start getting immediate feedbacks, and that's how you can improve faster. Finally, repeat this process until you are done or satisfied with the solution. Just to recap, if you are to implement an IoT solution, think of 3 important factors. The first is business relevance, second is total cost of ownership, third is time to market. And I'll end my presentation with this slide, which will help you walk through. This is a bit elaborated slide and may take time. If you want, I can share this with you. So that's me. Thank you very much. You can contact me with the email ID. So any questions? Happy to answer.
Anyone? You can ask a few questions.
No questions.
I can come, yeah.
No one? All right.
Yeah. Thank you.
Thank you so much, Mr.
Thank you.
Bhandari. Once again, thank you so much. And now this is for all the delegates. Please don't forget to collect your delegate bags that is there at the entrance at the registration desk. And now I would like to invite Mr. Vinay Gupta, Head Data Analytics, Suzlon Energy, and he's going to talk on the topic AI and IoT applications in renewable energy. So can we all give him a big round of applause?
We want